section 7.5, we get introduced to these scary looking formulas, which are actually not that scary to use, they just look really big. They would be hard to remember if you didn't have them on your formula sheet because they look so much the same. But what this means is that if you have two different angles added together inside of sine, sine is a function. You cannot just distribute. So the number one mistake here is someone thinks that if I have two different angles, this does not equal, I can't just distribute a sine. You can distribute numbers, but sine is a function. We can't distribute functions. We weren't able to do that with square roots. You can't just square root individual numbers separately. We can't do that with functions. And we have these very big formulas for figuring them out. So what we're going to do, we're actually going to start with example 2. And there's those very big formulas for sine and cos, and there's also on page 638, two formulas with tangent. So what your job is in identities and moving forward with questions like this is you have to recognize that you are allowed on your formula sheet any of those formulas at any time. If you have the right side, you can change it to the left side. And if you have the left side, you can change it to the right side without having to show any work whatsoever. You just have to recognize which formula you have and how to change it. So for example, in this first question, I have sine cos minus cos sine. The first thing I would do with my formulas, these new formulas, is I would memorize the basic structure of them. If you have sine, cos, and cosine, and 4 of them added or subtracted, that sure looks like one of these new 4 formulas that we've had. Do I have one that looks like this? Sine alpha cos beta cos alpha sine beta. So I'm going to make alpha 8x and beta 3x, because those are the two different angles that I have inside. And is there one that looks exactly like this? Yes. I go to my formula sheet and I notice that sine alpha minus beta is sine alpha cos beta minus cos alpha sine beta. Does that match up perfectly? It does. Sometimes they're going to match up close, but not exact. And then you have to do a little bit of algebra manipulations to make them match up exactly. This one matches up exactly. So that means that I have the right-hand side of that formula, and I can change it to the left-hand side. My alpha was 8x, my beta was 3x, and of course that would simplify to sine of 5x. Look at your formulas on page 638. If I make my pi over 6 alpha and my pi over 12 beta, is there a tan alpha plus tan beta over 1 minus tan alpha tan beta in our formula sheets? And I'll just write it down. So on our formula sheet we have tan alpha minus tan beta. Does it match up perfectly? It does. Okay? And that allows me to take this in part B. I have the right-hand side. I'm able to write this as the left-hand side. Tan, alpha's pi over 6, beta's pi over 12. It was tan alpha plus beta. And here I could get a common denominator. This would be 2 pi over 12 plus 1 pi over 12 would give me 3 pi over 12, which reduces to pi over 4, which is equal to 1. That whole thing is equal to 1. So these new formulas, part of what they're going to do is that we're going to be like, if you have the left side, you can write it as the right side. And these first kind of questions just get us used to working with those formulas. Then we're going to find out that these formulas allow us to figure out things on our pie plate that we're missing. I don't know if it bothered anybody else that the spacing wasn't quite, like there's 15 degrees between 30 and 45, but there was 30 degrees between 0 and 30, 30 degrees between 60 and 90. With these formulas, we're going to be able to cut those in half and do the 15 degree family, the pi over 12 family, without our calculator. So, just a little history of math. The unit circle allowed people to do trigonometry, a fair bit of it, without a calculator. And before you had calculators, that was kind of a big deal. Now that we have calculators, it's sort of not as big a deal because we can definitely use calculators to figure out a bunch of stuff. But what we're seeing is how mathematics was developing, so now we can figure out other things without the need of a calculator. All right. Questions to circle for number 2, 4, and 5.